Hi guys, good day Captain. This video will explain on how mariners in the past determined their latitude and longitude without modern day technologies of GPS in the past. These are the two common instruments that were being used for navigational purposes back then. As you can see the first picture, this instrument is called the sextant. And secondly, on the right, this instrument is called the chronometer. A sextant is a doubly reflecting navigation instrument that measures the angular distance between two visible objects. The primary use of a sextant is to measure the angle between an astronomical object and the horizon for the purposes of celestial navigation. A chronometer is an extremely accurate clock or other timepiece. Chronometers are used in scientific experiments, navigation, and astronomical observations. It was the invention of a chronometer capable of being used on board ships in 1762 that allowed navigators for the first time to accurately determine their longitude at sea based on Greenwich Meridian Time (GMT). Latitude. Latitude is a geographic coordinate that specifies the north-south position of a point on the Earth's surface. Lines of latitude measure the north-south position between the poles. The equator is defined as 0 degrees. The North Pole is 90 degrees north, and the South Pole is 90 degrees south. In simpler terms, latitude is an angle which ranges from 0 degrees at the equator to 90 degrees at the poles. Lines of latitude are all parallel to each other, thus, they are often referred to as parallels. Longitude. Longitude is a geographic coordinate that specifies the east-west position of a point on the Earth's surface or the surface of a celestial body. It is an angular measurement usually expressed in degrees. Longitude increases as we travel east or west of the prime meridian. Meridians connect points with the same longitude. The location of the prime meridian, 0 degrees longitude, is completely arbitrary, and the current 0 degrees line is at Greenwich, UK. A sextant is a very important mathematical instrument for navigation at the sea. The primary use of a sextant is to measure the angle between two far away objects. Most often, these objects are the sun and the horizon, or the pole star and the horizon. To find the latitude, we must find the angle of elevation of the sun by using the sextant. And we also must know the season. So the reason we need to know about the season is because the angle changes with the seasons.
So to determine the latitude with the help of a sextant, I have an example of a sextant altitude which is 66 degrees and 10.6 minutes. So with the help of the Nautical Almanac book, we can determine our latitude without the modern technology of GPS. As for the sextant altitude, it is the observed altitude as observed by the sun, and it is the angle at the observer between his visible horizon and the body. As for the index error, it is based on the Nautical Almanac book. Moving on to the observed altitude, it is the observed altitude of a body corrected for any index error which may be present in the sextant. As for the dip, it is given by the Nautical Almanac book as well. Moving on to the apparent altitude, the apparent altitude of a body is the observed altitude corrected for dip. be subtracted from the observed altitude to give the apparent altitude. And as for the total correction, it is the altitude correction and it is based from the Nautical Almanac book as well. Moving on to the true altitude, it can be obtained by applying dip and total corrections from the Nautical Almanac book. In this case, the dip reckoning latitude is 23 degrees 40 north, while the declination is practically nil. Hence, the sun's azimuth meridian passage must be south, and so the true altitude is named south. To name the minimum zenith distance, which is the MZT, is opposite to that of true altitude. This naming system is a quick and sure method for you to decide whether the minimum zenith distance and declination are to be added or subtracted to obtain the latitude without the necessity of drawing a figure. And if the minimum zenith distance and declination are of same name, add and return the name. If of opposite names, subtract the smaller one from the larger one and retain the name of the larger one. As for the declination, it is given from the Nautical Almanac book as well. And the final step, to get the latitude, the minimum zenith distance will minus the declination. And then you will get 23 degrees 32.8 north. So to determine our longitude, open out at sea without the modern technology of GPS. Firstly, we have to master the sun's position, which is the rising, noon and setting. And rising is always 0600 on the horizon in the east, and 1200 is when the sun is directly at its peak, and setting is at 1800 on the horizon in the west. Secondly, the use of marine chronometer, which is the clock that is set according to Greenwich Meridian Time, GMT, is highly beneficial for sailors to determine their longitude out at the open sea. And since there are 24 hours in a day and 360 degrees in a circle, the Earth rotates at a rate of 15 degrees per hour. How do you get 15 degrees per hour? Is by 360 degrees divided by 24 hours, you get 15 degrees per hour. As for example, when the sun is at the top of its peak, which is 1200, the chronometer indicates that the GMT is 1430, which means we are behind time. And the time difference is 2 hours and 30 minutes, which is 1430 minus 1200. You get 2 hours and 30 minutes. So what is our longitude? First, you times the 2 hours times 15 degrees, you get 30 degrees. Secondly, your 30 minutes divided by 60 minutes equals to 0.5 hours. And then your 0.5 hours times 15 degrees, you get 7.5 degrees. You added up both these 2 degrees, which is 30 plus 7.5, you get 37.5 degrees west. And why west? Is because the reason if our local time is behind GMT, which means we are traveling west. If our local time is ahead of GMT, means we are traveling east. And that's the end of the video. Thank you for watching. And you can find out more about the longitude and latitude at Wikipedia. There's a book named The the illustrated longitude, which is the true story of a long genius who solved the greatest scientific problem on his time. And there's a documentary about the search for longitude, which is Nova, Lost at Sea. You can find it on YouTube as well.